Tá no ar.
Fala pessoal, tudo bem? Boa noite a todos. Espero que todo mundo tenha tido um ótimo final de semana por aí. Com exceção do Vitor, né, que teve que trabalhar, teve plantão. Pessoal, é o seguinte, hoje a gente tá aqui com um convidado que é o Warner. Ele é o nosso principal consultant. Ele é o nível de suporte 3 lá na Pythian. E a gente queria que ele falasse um pouquinho. Ele vai falar aqui um pouquinho com a gente sobre encontrando um problema com o profiler e extended events. E também vai falar sobre capturar planos de execução. Ok? Assim, eu estou falando em português agora, mas vai ser tudo em inglês, tá? Porque ele fala espanhol, ele fala espanhol e inglês. E qualquer coisa vocês postem as perguntas aí que a gente vai tentar tirar que a gente vai tentar traduzir para vocês, tá? Hey Warner,
Yep.
good evening. Thank you very much. We're great here. Thank you very much for sharing your precious time with us.
Yeah.
Thank you very much. And thanks for using the t-shirt as well, the Brazilian t-shirt.
Representing.
Yeah, great. So whenever you're ready, feel free to start.
Okay. Let me see if I can share my screen. Let me know once you can see a PowerPoint.
All right. Oh, there you go. January 2017. Yeah.
Yeah. Okay. Perfect. Go in slideshow. We're good.
Yeah.
All right. So let's get started. So topic for today is going to be profiling queries with extended events and DMVs, and we're going to focus on some more less known newer DMVs. One of them was introduced in SQL Server 2014, and the other one was just introduced in SQL Server 2016 Service Pack 1. So we're going to have a couple of things that are very new in 2016, just fresh out of Service Pack 1. So introducing myself, I've been working with SQL for about 11 years now. I used to work in Hewlett-Packard out of Costa Rica as a level 3 DBA, and I work now as a principal consultant at Pythian, which is a consulting and managed services company in Ottawa, Ontario, Canada, but we have employees all over the world. I'm a SQL certified master and data platform MVP. You can reach out to me on Twitter at Warchaf. Feel free to shoot me an email, warner@sqlturbo.com. And if you want to check out the blogs where I put material on, it's sqlturbo.com. And also we have a tech blog at pythian.com as well. All right. So the agenda for today, the goal is to show some of the profiling capabilities that we have with extended events, and also that we have with some newer DMVs. So one of the DMVs is called DMExec Query Profiles. It's available in SQL 2014. The other one is called DMExec Query Statistics XML. And that one is available in 2016 Service Pack 1. And we're also going to look at a trace flag, a new trace flag introduced in 2016 Service Pack 1 that does a very cool thing that we have never been able to do before. So we're going to learn about that on the demos. So demos, this is going to be a very demo heavy hour. So I'm just going to have like 3 slides, I think 3 or 4 slides, and then we're going to go straight into the demos. Demo number 1, we're going to do some response time analysis, meaning we're going to collect wait events. We're going to be collecting individual wait events attached to a session through extended events. Then we're going to see how we can profile a query with both the DMExec Query Profiles DMV and the DMExec Query Statistics XML DMV. So we're going to see how we can profile a query with those 2 DMVs and the type of output and results that we get from both of those DMVs. Then we're going to look at a very interesting case of using those DMVs to profile a more complex query than the one we're going to use for the example number 2. Extended events again, and this time we're going to look at profiling the I/O activity and pattern of SQL Server in relation to a particular session. All of that using the extended events target that is called the bucketizer. And we'll look into what the output looks like and how we set up that session later on in the demo. And finally, we're going to bring it all together. So we're going to show how we can integrate the results of the response time analysis, integrate the results of the exec query profiles, and integrate all that with also the IO information that we collect. And hopefully, my goal is to give you guys spark up some creativity and imagination in how you can use these tools to combine different information in a similar way. Okay. So before we get started, a couple of things to clear up. This is not an introduction to extended events. I assume you at least know what extended events is. If not, you're going to catch on pretty quick because it's a very demo heavy session anyway. Again, this is also not an introduction to dynamic management views. If I assume that you are a junior or intermediate DBA, you know what DMVs are, how they're usually used with SQL Server, and so on. And concepts, very general concepts of SQL OS, like a task or a thread. I assume that those are known as well as basic concepts of execution plans, like, you know, cost or actual versus estimated and all that kind of stuff. All right. And that's it. That's all the slides I have. So let's jump right into the demos. So I'm going to switch over to an Azure VM. And Marcelo, you can let me know if you can see the
Yes.
the Management
Yes,
Studio screen.
Management Studio, and the resolution is good for me.
Okay, perfect. So let me
Very,
make
very
sure
nice.
that I have Zoom it. So I do have Zoom it. So we're good there. Okay, perfect. So
Oh yeah,
Zoom it is good.
absolutely, absolutely.
All
Yeah.
right. So first, let's this is demo number one. So demo number one we're gonna do is a very simple response time analysis with extended events. And the nice thing about extended events, if you haven't used it much, is that it is a lot easier to read what it is collecting compared to Profiler. So if you guys are experienced with Profiler, you know that Profiler, when you create a session, it's a bunch of number codes, and the number codes define the events, and then there's more number codes that define the columns, and then there's more number codes that define the filters, right? So it's a pain. It's a pain to actually read a Profiler script because you have no clue what it's doing. So this is advantage number one that extended events has. We can actually read it and understand what we're doing. So what are we doing here? We are doing a create event session on a particular server. Then we're going to add the first event that we want is this one, wait info. And this is a wait event that is produced inside SQL Server. So that's event number one. Then event number two that we're going to capture is a wait event that is external to SQL Server. So this could be an wait event that happens in the operating system. Now, for both of those events, we're going to filter on a particular session ID. In this case, I'm going to filter on this session ID that I have on the window open. In my case, so this is not 68 anymore. This is when I ran the demo last time. Now it's 61. And then we have to decide where we want the results of our extended event session to go. So this is where we have this target. And in this case, I'm going to pick just an event file. These event files, in very early versions of extended events, like in SQL 2008, you were not able to open event files or Management Studio. You had to read them through T-SQL and then do the XQuery stuff. Nowadays, it's really easy. You drag and drop them into Management Studio and you can analyze them. File name, I'm just going to pick a file name here. If I don't put a path, it's going to put it in the log folder of the instance, all right? And then here you have some more advanced settings that I'm not really going to go through, other than to say, if you're really interested in, you can look on books online or check out other material for extended events, and other people have covered what each one of these more advanced settings do. All right, so here, again, we're going to attach ourselves to session 61, and we're going to analyze the weights on that particular session. So I'm just going to run this now. Oh, I already existed, so let me just drop it. That's probably for me practicing the demo earlier. So let me drop it. I'll delete all these that I used for the demos so that we can recreate it. And that's one. Okay, there we go. Okay, so now we recreated it. It's brand new, fresh. You can always look here at Management Studio, and they're all under Management Extended Events Sessions. So we see now here, if you have never looked at it with Management Studio right now, here it's created, but you can see the little arrow there pointing down because it's stopped, right? Okay, so and actually what we're going to do is we're just going to start it with the GUI here. And now it's up and running. So what it's going to do now is going to capture every single weight that I do. So I'm going to connect to a demo database that I have right here called HR. And I'm just going to run this store procedure called salary analysis. And this is a demo store procedure that is doing a bunch of manipulation of the data just so that it creates load and activity so we can see the weight information, right? So I'm just going to run this. And we're just going to let it run. It should run in a few seconds. Usually doesn't take more than, 10, 11 seconds or so. Oh, there we go. It's over. So that's 7 seconds. And once we have what we wanted, the session that we wanted to analyze the weights on, then we can safely go here and stop it. Now we can go into the log folder and we can go find the file. So we see here, here's the file at the top of the log folder. You guys see the one I created, RTA analysis.xel. And like I said, nowadays on Management Studio, it's very easy. You just drag and drop that file, and it actually will be opened with Management Studio, and you can manipulate it with Management Studio. So here we can see all the different weight events that happen in this particular session. You guys see here right now, I'm just scrolling and scrolling. It says memory allocation and what type of thing it was. So first thing you want to do is, let's say we wanted to analyze these and see how many different types of weights happen during our session. So the first thing you want to do is we want to manipulate here this extended events session. You can see here there's a menu at the top. When you're opening one of these files, it says extended events. And what we want to do is here choose the columns. And right now at the top, you guys can see we're only seeing name and timestamp, but there's more that we can add, right? So let's add the weight type. So we're going to add the weight type to the top. Then we can see now we have each one. We can see at the top what the weight type is. Once it's like that, we can group them. So we can group them by weight type. And now that they're grouped by weight type, we can see the profile of this particular store procedure that we're trying to analyze, right? So the whole goal of today's session, like I said, is to be able to put like a magnifying glass on top, a microscope on top of a particular problem store procedure or problem session, and being able to analyze it to, the most granular degree. So we can see that store procedure used 5 different weight types. We can see very little as far as I/O or reading data files, so we know that's not really an issue. We saw that it did some sort of memory allocation while probably while it was reading the data, or maybe the table got created and then we had to allocate some memory to it. And we see there was 800 weights to write to the transaction log and 1600 SOS scheduler yield weights. Now the interesting thing here is that just by looking at this list of weight types, you might be thinking, well, the problem here is really CPU pressure, because there's a lot of scheduler yield. We're yielding the scheduler constantly. It means we're chewing up a lot of CPU, because that is the top weight type, and it's double the time of the write log weight, right? So, but is that really correct or not? Because what we're missing here is that this tells us that there was this many weights, but it doesn't tell us how long each weight lasted, right? So that's where we can go back here, choose columns again. You guys see here, there's a duration column, and I'm going to add it. So I have duration added, and now I'm going to change here is the aggregation. So I want duration to be summed up. Okay, and I want this to be sorted as well by the sum of all the durations, and I want to see it descending. So if I say okay now, we can see it totally changes. In fact, our system did only 2 IO waits, but that actually took 230 milliseconds, compared to our system did 1600 SOS scheduler yield wait. So 1600 times it waited for the CPU, but they were so short that for SQL Server, it's pretty much equal to 0, right? So we can see how two IOs on, two waits on a subsystem that is particularly slow, which is the disk in my laptop, takes 230 milliseconds, as opposed to 1600 waits on a subsystem in my laptop, my CPU, that is pretty fast, and that actually takes 0. And we can see how actually the worst wait in this particular store procedure is write log, and it's 800 waits, so it's half as many as we had on CPU, but it was actually 2.5 seconds waiting just to write on the transaction log, right? So I hope that really makes sense, how we can capture specific waits related to a specific session. We can count them, but counting them doesn't really give you the entire story. We need to measure how long they last. That is the entire story, and that's what we could analyze. If we wanted to, let's say, try to improve this store procedure, then we could look at either trying to decrease how much transaction log it is writing. We could look at using a feature such as delayed durability, which was new into SQL 2014, which can batch up the log writes and make less and bigger log writes. Or we could look at just getting faster, log drives to put our transaction logs maybe on some super fast SSDs or some super fast NVMe cards or something like that, right? Okay, so this is demo number one. We'll keep it in mind as we, like I said, progress all to the way to the last demo of how we can do weights analysis with extended events. So pretty cool stuff that we have here. So I'm just gonna stop it now. Gonna close this one. And we already stopped this particular extended event session. So I'm just gonna close this one now, okay? All right, so now we're gonna move over to demo number 2. So let me switch over to a different window. So demo number 2, we're gonna start with a very simple query, and you guys will see soon why I have this split into 2 windows. So let me make this a little bit narrower here. Okay, so on this side of the window, on the left side, I am connected to that HR database that I was talking about, and I am going to I'm going to drop the buffer cache just so that this runs for a few more seconds, so it gives me time to show what it's doing. And on this right-hand side, we're going to be using this new DMV. So I'm going to explain what I'm doing here on the right-hand side. So first, I did a setup here of selecting into a temporary table from that DMV, because I'm going to be storing the results of that DMV into that table. So to reset and start the demo, I need to truncate that temp table. That's it. And now what we're going to do is we're going to look at the session ID that we want to analyze. In this case, it's 54. So let me just replace that here. So 54. And what's going to happen is we're going to start a loop, okay? So we're going to start a loop inside this session. And this loop is going to look into inserting data into that temp table of this query statistics XML with that session ID. And as long as there's, this query is running, this loop is going to continue inserting this analysis, capturing data from this DMV. And once this session is over, this loop is going to detect that there's no more rows coming in from this particular session ID, and it's going to end. And then we're going to be able to analyze the results, okay? Now, the tricky part here, or the more subtle part, is that in order for these DMVs, both this query statistics one and the query profiles one that I'm going to show next, both of these DMVs, in order to actually capture information, you need to do a couple of things. So if you are the one that is running the query, you can actually just use include actual execution plan or include live query statistics. Either one of them will populate these DMVs if you're working here with Management Studio. But that is only if you have actual control of the session, right? So the capability that we never had before is the following. Say you get a call from somebody at your work, and they say, or a client of yours, and they say, hey, Vitor, or hey, Marcelo, I have a report, and I've been running this report for 16 minutes now, and I want to know what's going on. Why is it taking so long? Or how much more work does it have to do, right? Like, are you able to answer that question today? Before 2016 Service Pack 1, you had no clue what that particular thing was doing, other than you can go to exec requests and try to see the command that it's running, and then try to figure out what table it might be locking, but you didn't know what exactly in the execution plan it was doing. So that is what is fixed, or what is added in SQL 2016 Service Pack 1. So in SQL 2016 Service Pack 1, if I turn on this trace flag, and this is a supported trace flag, 100% supported, is not some weird undocumented trace flag that Microsoft support is going to get you in trouble. Nothing. It's 100% documented, 100% supported. You run this trace flag, you can attach and analyze the execution plan of any session that is running on the system. Now, there is a performance penalty, but Microsoft says that they implemented this in such a lightweight way that when you turn on this trace flag, it only has about a 5% performance impact on your machine. So that is a really low percentage considering the really powerful capability it gives you. Like I said, it means that if that scenario where somebody already started the query and you need to know what that query is doing, if you turn on this trace flag, you can know exactly what operator that query is actually running at any given point in time. So that is more, I would say that's pretty fair, that if that costs 5% of less performance in the entire server, I think that's okay. So we're gonna turn it on so you guys can see the full capability here. So I turn it on. Now I'm gonna go back here. And like I said, this is gonna be a loop that's just gonna be continuously running. So I can execute it, and you guys will see it'll just stay executing forever. As long as I'm not running this window here, this loop is never gonna end. So what I'm gonna do is I'm gonna run this session now. And then we'll see once this session is over on the left side, then the loop on the right side is going to end. So let's just wait for that query to finish. It does take a few seconds so that we capture enough information, and it's kind of interesting to see. There we go. So we can see it took 17 seconds to produce 100 rows of results, this particular session. And we can see the loop here where it didn't insert anything, and then once I kicked off the session on this side of the screen, it started to capture information. One row, all of these. All right, so they started to capture all this information. So what is the information that it captured? Let's go check it out. And remember, I did not turn on the Management Studio options here. This could have been a session run by somebody in another country connected to my SQL server on their own Management Studio, on their own application. It doesn't matter, thanks to the power of this new awesome trace flag, right? So let's just go to the output now and see what we captured. Okay, so let's see what this is. Now what I have here, and let me minimize this SQL handle column and the plan handle column. What I have here now is the time. So I can see the first capture of this particular execution plan started at 18:28 at the 29th second, and it finished at the 43rd second, right? And now what we can see is if we click on the query plan column, I can see the actual query execution plan as it was happening when I was capturing through that loop. So we see, for example, the first row shows me the execution plan on the first second that the query started to run. And we can see, for example, here then, because this is at the first second, we can see really cool stuff. Like it estimated that it had to read 20 million rows, and on the first second it had read 800,000. And now we can see if we move further down the line here, actual number of rows actually say 0. All these, and after here we can see that actually there's no actual number. And the reason for that, and some of them still say number 0, is because the plan hasn't progressed this far after 1 second, right? The plan is still doing all the work here. Very cool. But now then, the interesting thing, of course, is that we can track it through time. So we can go halfway through what we capture, let's say row 7. So that's 7 seconds later, and we can actually click and see what has gone at this point in time. And we can put ourselves here. We can see after 7 seconds, we have already read 9 million records from that table scan, right? And we can still see the progress here. There's no actual rows that have flown through the rest of the execution plan. So we can see actually this operator here, already half of the execution plan has all been inside this table scan operator. Okay. And then last one, just to show you guys, if I go here again, I can see that even at the last capture, if I go and see what this is doing, we are at 17 million records read out of 20 million. And then on the next second, the whole query was over. So that means that pretty much really most of the work, or like 99% of the work, even though we can see here that SQL is saying the cost is 43, cost is 57, but really we know, because we measured it with the time, that most of the time, regardless of the cost, most of the time was spent only on this table scan. Because right here, this is the last second of the plan, and we can still see actuals are at 0, right? Even though we know at the end we're going to get 100 records returned, right? So again, very cool stuff. This particular view was introduced as well in 2016 Service Pack 1. So we did not have this capability to be capturing actual query plans as they progress through time until 2016 Service Pack 1. So what we had before that was introduced in 2016 was the live query statistics. And the live query statistics uses this other DMV that I'm going to show you guys now. So this is this one that's called DMXEC query profiles. And if I run this, the DMXEC query profiles, you'll see it gives all sorts of different stuff. It basically takes those properties from the execution plan and shows them as columns, right? So estimated, the row count, the actual row count, the elapsed time, the CPU time, the object, all that are actually columns inside the DMXEC query profiles view. So both these two views are similar, but they show the information in a different way, right? The statistics XML shows it as a progression of execution plan, whereas the DMXEC query profile shows it as a progression of the specific operators inside the execution plan. So let's run the same thing. Let's do the same analysis. In this case, what I'm going to do is I'm just going to rerun this same problem query, and we are going to capture the information on the DMXEC query profiles. So this one will behave the same way as the one that I just showed you. I just execute this. Let me see. There's the issue here. Oh, I see. Do you know what? I think Microsoft must have added a new column to this DMV, and I created this first on a previous version of, I created this demo, this query exec profiles demo when it was introduced in 2014. So let me recreate this. And I'm gonna truncate the table. And let's see if that, there we go. So that is, so they probably added some columns between 2014 and 2016. I didn't even know. So there we go. So the loop is going to continue again until I run this guy here. I'm going to run it now. And now we'll see how long it takes. It should take less because the buffer cache is warm. There we go. Now it took 5 seconds. And this one here, let's see if it is over now. Okay. And we can see what the results are. Okay, so this is session ID. Oh, I forget a word clause here. So I'm interested in session ID 54. So here. So that's something to watch out for because it will capture all the info of a bunch of other sessions that are running. From the order by. Okay, so now we see session ID 54. So interesting here as well. This is like a different way to see the execution plan. But we can see, for example, the progress of the table scan that is happening here. And we can see as it goes through time, we can see, for example, that there were, let's see, 1, 2, 3, so it's 4 threads being read and a master thread there, so there's parallelism. Each thread has estimated that they're going to read 5 million. Remember, the total was 20 million. So that kind of information is harder to see on the execution plan. And the execution plan, the graphical one, it's easier to see the total that we're reading, not so much how it's split. So here we can see how each thread progresses through time as they reach close to the estimated of 5 million. And this is the last capture we have for this session. So after this, after they got this close, then the rest of the execution plan continued really fast, even before we were able to capture it. If you want to capture even more aggressively and have more samples, you could just, you know, here I'm just doing a wait for 1 second. But if I change this wait for 1 second to wait for like, you know, let's say 0.5, so now I'm waiting for half a second before I capture. Now that obviously means I'll have more rows that I would need to analyze, but I mean, that's just how it is. Let me add this word clause here as well. And we can run this other query. And now we can see here as well, I can get by joining with the other DMVs, I can see the text that I was running, and I can get the estimated execution plan of a particular this particular query. So this is the estimated one. So we'll see there is no actuals on this one because this is taken from the plan cache, right? This is not the live one. So if I want to get the live one, I need to do what I did here with the query statistics XML DMV. If I just want the estimated one, I can just join it with the classic DMExec query plan DMV, just how I did this here, right? So it's 2 different ways that you can get the info, but both of them work just fine. And they show slightly different things like we saw here with the results. We can actually see the progress here per thread, which is a lot more detailed, right, than just the graphical view of the execution plan. All right. So that is demo number 2. So now this is a particular query that we analyzed. Let's move on to demo number 3. And we're going to do the same thing, But we're gonna see something very interesting in the behavior of demo number 3. So let me move this here so we can see the entire query on the left side. I'm gonna remove the join. There we go. So we're gonna repeat the same thing. So I'm gonna reset this statistics XML one. I'm gonna reset it, and this one is session 57. So I'm gonna change it there for 57. I'm gonna run the loop. The loop is running, and then I'm gonna run this here on session 57, and we're just gonna wait for it to end. So remember, we're doing the same thing in this case. So we got the rows that it captured. Now let's go and see the results. So again, remember, this shows us an execution plan progress through time. So we can come in here, we can click on the first one. We see clustered index scanned and a cluster seek. And as we go through the execution plan, we see the actual number of rows here progressed all the way to the end, where it's actual 9 and the estimated is 9. And we know the result here is also 9 as well. Okay, so that was the statistics XML. Now let's check it out with query this DMXEC query profile. So I'm gonna reset it. So I've reset it, and I'm gonna run the loop. It's capturing now. I'm gonna capture this guy again. And it is over. I'm gonna go back to this one, and I can stop it. And let's check out and see what we captured here. Now we can see here, it's session 57, correct? Okay, so we have here stuff that we captured from session 57. Now we'll see something very interesting here. So let's compare the output here. Okay, so let's see. According to query statistics XML, this is the execution plan for this query on this side, and it's doing operations on this salary table and this employees table. Very simple loop, compute scalar, and we have our result, right? But now we look at the DMXEC query profiles, and we see there's like multiple threads here with fairly high estimated row counts on a table called imported data. And this table is doing a table scan, and where is it? It's nowhere to be found in this execution plan, right? And this is a awful weakness that still exists in SQL Server today and is related to the use of functions, right? So this is, if somebody were to ask the SQL team, they would say that this is something they would love to improve. They just haven't had time to do it. But basically, the optimizer does not top-level execution plan does not give you visibility over the functions, over the scalar functions that are executing in the query. Now, here, my example is very simple, right? So it's easy. If one of us was to sit down and just read it, then we would be like, okay, salary, DB, there's a function here. Something else could be going on. This might not be the full execution plan, right? But imagine this was a massive SQL report. I've had clients send me SQL reports that are like 8 pages, right? They're like really large queries. So imagine, what do we do in those cases? We might not even have it might not even be possible to be reading line by line until we find something, right? So just keep in mind, these can be lying to you. They might not be telling you the whole truth. The only one, and this is the comparison that I did now that this new XML DMV came out. So unfortunately, this DMV, if it's a really large SQL query or report, and you want to capture this type of really detailed information, this DMV is going to obscure the functions if there are any on the code. However, this other DMV, DMExec query profiles, right? Here it is, DMExec query profiles, does not obscure it. And it allows you to discover weird things like this, like what is this HR imported data? Why is it suddenly something that I didn't see at all in the code, or I didn't see it in the main execution plan? And not only that, but with DMExec query profiles, if we were to run this and run the analysis query that joins back to the other DMVs, we can actually see there imported data, and we do see it here. So very easily, if we were to just see this visually, once we join it back to the other DMVs, and if you were going through the results, you would be able to right away be able to tell, oh, there's a function. There's a function that's screwing up the performance of this whole thing. So again, very easy here because I have a very small example. It's just a demo query. But imagine if it was a really complex query, or even worse, like we've had people that have views inside views, and then the low level view is the one that has the function. Good luck finding that, right? It's a pain. Here, really easy. We join it back to the SQL text DMV, and we can, just from visual inspection, we can right away tell that there's a function going on, and we can right away click here on the query plan. Boom, we can see the query plan of the function itself, and we can see that, yes, we are actually missing an index, so that SQL does not do this table scan that is happening every time we call this function, right? So very powerful stuff, and trust me, when things can get really complicated, very tricky, this is very powerful for really quick troubleshooting of things that can be causing a lot of slowdown, but are not easy to find through the top level execution plan. As you guys can see here, there's no function at all on the top level execution plan. Okay. All right, so that is demo number 3, and we got about 15 minutes to go. So let's just jump right over to demo number 4. So demo number 4, we're gonna do something kind of similar. First of all, my session running this function is session 57. So what we're gonna do here now for demo 4 is that we have a new extended event session. And on this new extended event session, I am going to capture these events called file read completed. And here I'm going to filter them by the session that I want, which is session 57. And I'm going to use this target that's called a histogram. What this target does is that it takes an event, in this case, the file read completed, then it takes a column, in this case, the size, and then it gives you the option of actually creating buckets based on the size of the file reads that have happened, right? So here what that means is that every time, let's say, an 8 kilobyte read happens, it's going to increase that number in that bucket. So it's going to say 1. Another 8 kilobyte read happens, it puts 2. Another one happens, it puts 3. A 16 kilobyte read happens, it starts a new 16K bucket, and it says it's happened 1, and so on. And you can do this with any type of event. It could be done with like memory allocation. It could be done with like a CPU related event. It could be done with like an AG event related event, anything that you can think of. You could do the same type of histogram. Every time that you want to find out how many times something happens and it's different type of values inside an event, this is a good target that you can use. Now, the tricky here part, not tricky, but the only part that is different is that the histogram target does not go to a file. The histogram target stays in memory. So we have to analyze it while the session is still running. And once we stop it, the results go away. So it's always good to insert it into a table that you can analyze after the fact. So let's create the session. So it's created now. I'm going to drop the buffer cache so that we generate reads. And then I'm going to start this session. And now what I'm going to do is go back to my other window and run the problem query with the function. So I'm going to run it now. This should take a few seconds to run. We have a cold buffer cache so that we are actually doing file reads. Remember, that is the important part because that's what we want to analyze with this extended event. So now that that's done, before I stop it, I have to store it into a temp object because remember, this particular result is in memory. This histogram target is in memory. So we can see I capture 15 rows and we can actually analyze it now. So let's look at what SQL Server was doing. So we know that there was a lot of table scans done by that function under the cover. So what does SQL Server do when it has to read a lot of data? It pushes the size of the I/O to be as big as possible, right? And we can see some big I/O sizes here, and we can see the amount of I/O sizes done by SQL Server, right? So we can see 64 KB IOs, even some really big ones like a 4 meg IO done by SQL, 1 meg IOs done by SQL Server. So obviously, you know, full scans, SQL Server will start doing even read ahead, so it reads even bigger IOs. But this is just to show you guys that we can actually see the size of the IOs that SQL Server is doing at any given for any given session. With extended events, we can see even the size of the IOs that are being captured, right? So once you have this on a temp table, then you can stop the session. And once you stop the session, if you wanted to read again from it, it would be empty, pretty much. That's all it means. This histogram target is now empty. And if I were to rerun this, it would just not capture anything into the temp table, right? So the last, you need to take the results, put it into a temp table, so or in a permanent table, up to you, and save them so you can analyze them later. And after that, then you can stop this extended event session. So pretty cool stuff. Again, this is only possible with extended events where we can create get to this level of detail where we see the sizes and how many IOs SQL did to satisfy a particular query. Very powerful stuff. This also means, for example, if you were trying to profile the exact I/O pattern of a server, you could run this for a small period of time, and it would give you an idea of the typical I/O sizes or the most popular I/O sizes for your instance. And then you could maybe run like a test with this speed. If you were to migrate to a new machine, for example, or if you wanted to test out making a bigger VM or something like that, you could test the I/O sizes that you know that your SQL Server is using because you actually capture them with extended events, okay? So very, very cool stuff. Now, as we go here, we're gonna put it all together for the last demo of today. We have a few minutes left. And what we're going to do is create a new session, a new extended event session that joins the things that we were just capturing before. So we're going to have this event, the file read completed, and we're going to filter by the session ID that we're going to be tracing, which in this case is going to be our crappy query. And this is going to be still session 57. So that one's already correctly populated here as 57. We're going to capture again the weight info, and we're going to capture again the weight info external. Now, if you guys notice here, I am also going to capture something else. It says action, and this is task address. So this is going to let me map those the different things that the different threads are doing based on their task address through extended events, right? And this one is going into an event file, and we're going to be able to read off of that file. So here, I'm just going to go in and start this guy. I'm going to drop the buffer cache so that we have IO information to capture. And I am going to start the IO sizes and weights extended event session. So it started now. Now what I'm going to do is on the other side, I'm going to do the exec query profiles capture, which is this one I have here. So I'm going to reset it. So it's reset now. And I'm going to put my where clause here so that I'm only going to capture for session 57. So we can run this loop. And it's just going to start the loop. And now we can run the actual query that we are interested in. And we'll just let it run like we saw before. It should take a few seconds. So at this point in time, this query, we are capturing, not only are we capturing the IO, we're capturing the weights, and we are also capturing the information here from the mexec query profiles, right? So we have all those things together now. Session 57. And let me see here, if we go through the results. In this case, I should have not put this here. It's okay. All right, so putting it all together, let's say, for example, I can see the IO data that I captured. I can see also here, I don't know how long it's going to take to read off of this one, so it might take a while. So I'm just going to show you guys what it is, and then we'll put it all together in the end. So I have a query here that will read off of the extended events file and capture that amount of IO that we did. I have another one that will capture out the amount of weights that we did. And then we can obviously create, in this case, a CTE that will process the IO. So it creates this IO table. Then another CTE that processes the exec query profiles information. And then another CTE that captures the weight information as well. And then it just puts it all together and orders it, and you can make like a really detailed report of what a particular query is doing. So let me, and this might take a while because it has to read off the disk. Oh, I need to go to the HR database that I'm using. And let's see. If it takes too long, I'm just going to leave it running. We'll wait 10 seconds. And if not, I'll just go back to the slides to finish up and then come back and check out the results. Yeah, okay. So let's finish up with the slides and summary for today, and then I'll go back to the results. So recap, remember demo number 1, every single wait event of a particular session, we can find out what it is. Demo number 4, we can see even the size and how many IOs a particular session did. So that is how detailed extended events can get. If there's something you are interested in, it's very likely that there's an extended event for it. Now, if you want to analyze a query and want to analyze it to the deepest level and see how it's progressing, you can use those 2 DMVs that I showed, Query Profiles and Query Statistics XML. They are a bit peculiar in how they work. Make sure you play around with it. Like I said, and like I showed in the demos, you have to kind of loop. You have to loop through it so you capture all the different information in the view as the query is progressing. But as we saw in the demos as well, Query Profiles is actually more complete than Statistics XML. The Statistics XML can swallow the execution of a scalar function, for example, whereas Query Profiles, we were able to see that the function was actually being executed, and we were able to see the execution plan of the function being executed. If you are on SQL 2016, if you're lucky enough that your company already deployed 2016, you want to go to Service Pack 1 as soon as possible. Service Pack 1 2016 is awesome. Service Pack 1 in 2016 enables you to use in-memory column stores compression all in standard edition, and on top of that, it enables these performance goodies that I just showed, trace flag 2412, which allows us to see a query in progress that we didn't even start. It allows us to see any query running of our in our SQL server, attached to it, and see what it's doing at any given time. So trace flag 2412 and the statistics XML DMV, both introduced in 2016 Service Pack 1. And finally, there's other ways to combine the information and other things that the session would have been way too long if we start looking into other things, like, for example, looking into memory grants, looking at how SQL does network I/O, looking at CPU and how much CPU is being consumed as we progress through a query. All those things are possible if you use extended events and if you use these other two DMVs that give us really, really detailed information for an execution plan. And then we just have to correlate and put it all together. All right, so let me see if maybe the query is over now. Okay, cool. So this, it is over here now. But we are missing IO info. I wonder if it didn't capture IO info. 57. Let me see. Oh, it is, but maybe it's not joining on the task address. Okay, I would have to debug it here, but we can see that it did capture the IO info, but there's some reason why it's not matching up with the rest of the stuff. But if you look at it separately, you could see we did have IO info captured. And we can see actually even the type of IO that was captured, right? Scatter gather. And the sizes right here. And we also have the weight info captured. We'll see how long that takes. That'll take longer because there's a lot of weights that happen on any particular session. And it's got to load them all up in memory. Okay, so there we go. So we can see all the different type of weights that also happened and how long each one of them took for this particular, for each one of these task addresses. And then finally, we have also the information of the actual exec query profiles here, right? So we have the operator info that we captured as well here from the exec query profiles. So I think probably the problem here was that I started messing up with adding the filter here, and I think I need to wait and add the filter after the after all the information has been captured, so that some records don't get filtered out, and that should have been okay, but it's all right. Okay, so hopefully you guys got a good idea from the rest of all the other stuff, all the really detailed stuff that we can capture. And I don't know if maybe we have some questions. You guys can let me know. Preguntas.
Hey, Warner. This is Vitor.
Yes,
First
sir.
of all, thank you. Was a great session. There are a lot of things that I need to explore too on extended events. Was really good. Uh, I only have I don't have any questions here, but everyone is saying that it was a great session, and they are saying thank you to you for your time.
Yeah, for sure. For
Yeah,
sure.
me too. Was
Yeah.
really great.
The behavior of this trace flag 2412, like I said, I think that's at least for DBAs, production DBAs, this is a very cool new capability that, we enable this trace flag, and then we can attach ourselves to pretty much to any session running inside SQL Server. I think everybody that actually does production DBA support should familiarize themselves from now on with that trace flag and with using those DMVs that I showed to be able to see what a query is doing at any point in time, right? Like the typical thing of, like I mentioned, the example of the person that ran a report and they're like, I don't know what the report is doing. It's taking really long. Do you know? And then as a DBA, before we didn't have really a good answer because we didn't have these tools, right? Now we have tools like this trace flag and these new views that can really help us answer that type of question.
Yeah. Hey, Warner, just one question here right now.
Yeah.
If you can send me the scripts that you used on the session.
Yeah, for sure.
And then I can share with everyone.
Yeah, I'll send you the
Yeah.
scripts and you guys can play around with them.
Okay.
Sounds good.
Thank you again a lot. You let Marcelo to finish the session. I just want to thank you again. E também agradecer a galera aí que ficou até agora assistindo. Valeu mesmo por terem participado, foi bem legal. Eu fico muito feliz de ter o Warner aqui participando, um cara que está sempre em cima das melhores tecnologias. Galera, o vídeo vai ficar disponível, então se vocês quiserem assistir depois e compartilhar, fiquem à vontade, beleza? Cara, galera, da minha parte é só isso daí. Marcelão, quer fechar aí? Deixa eu só ver se o Marcelo ainda está conectado aqui.
We lost Marcelo.
É. Let me check again. I think. Yeah, that's okay. So, again, Warner, thank you a lot, and I hope we can have another session from you.
Yes, sir. Anytime.
Was really
have to let me plan, but yes. Other than that, for sure.
Really great. So thank you again, and I don't know how I can say thank to you because it was really great.
Okay, cool.
Okay?
Well, have a good night, everybody. Until next time.
You too, sir. Have a good night.
You too. Bye.
Falou, galera. Valeu, até mais. Tchau.